Okay, so I pushed the red button. So the question gives us the K, and it gives us a reaction. And it, oh no.
You messed up.
That's fine. It's perfectly fine. The question is, what are the concentrations at equilibrium? Okay, well, the first thing that we need to do is figure out what K is. So what is my expression?
Concentration.
Okay, NO2 squared. How come the bottom one's not squared? No coefficient, sure. All right, now here's what we need to think of. We need to make ourselves a little chart, and it's like we're writing an algebraic expression. So if we think about the concentration of NO2, and we think about the concentration of N2O4. So initially, what's my initial concentration of NO2? That's for N2O4. For NO2, it's 0. Okay. Now we're going to use some algebra here. So for my change, what's going to be my change in concentration of NO2? Or it's probably easy to think of what's going to be my change in concentration of N2O4. It's going to go down, so it's going to be something negative. And now, I don't know exactly what the number is. So I'm going to put in a variable. It's going to change by negative x. Now, if the concentration of N2O4 goes down by negative x, how's my concentration of NO2 going to change? You're half right. 2x. Very good, Eric. Eric, why'd you say 2?
Because there's 2 NO2s.
Yeah, for every 1 N2O4, we're going to get 2 NO2s. So it means if I lose negative x concentration of my reactant, I'm going to end up with twice the concentration of my product. So now, to finish off my little ice thing here, my equilibrium is going to mean that for N2O4, I'm going to end with a concentration that's 0.05 minus x. And that for NO2, I'm going to end up with the concentration of 2x. Yeah. Now, if I go and plug that stuff in, I know what my K is, because it says it right there. So 0.513 equals 2x squared over 0.05 minus x. Now I need to solve for x. I have good news and bad news. The good news is this is just algebra. You guys all got A's in algebra already, right? You know what the bad news is?
It's algebra.
Yeah. More specifically,
Quadratic equation.
this is a quadratic equation, isn't it? I thought you saw the last of that guy, didn't you? Not wrong.
Yeah.
So,
Does that mean I can just enter it in the calculator and go to where y equals 0.513?
you're assuming that you have a graphing calculator.
Yeah.
So, on, I guess let's go over to a new slide. That way I can do some maths. So, if 0.513 equals 2x squared over 0.05 minus x. First, I need to get this in a clean form. So I'll multiply both sides by 0.05 minus x. So I'll get, 0.513 times 0.05 minus x equals, no,
Still have.
still good, equals 2x squared. And then I'll distribute that out, and then I'll subtract it from 2x. So you guys can algebra. So I'll end up with,
We're all in trig right now. We don't know algebra.
it does, that's why I got 4 squared, I got 2 squared and x squared, or 4x squared.
Oh.
Yeah. Minus 0.02565 equals 0. There. That's the form you're used to working with for a quadratic, aren't you?
Yes.
Yeah. That's what's ready for a negative b plus or minus. Sounds like you've done a couple quadratics in your day.
Wait, okay, now,
Yeah, think.
how is the 0.513x positive with the x?
Because up there is a negative x.
Yeah, because I moved it to the other side.
Okay.
Move it over.
Is that AC on the top?
Yeah.
That's what I was thinking too.
Now,
I don't remember AC.
if you quadratic equation out, you're going to get an answer that x equals negative 0.1667 or x equals 0.0385. Because the quadratic formula, you get 2 answers, don't you?
Yeah.
This is true.
Well, now isn't that weird? Don't I have 1 equilibrium point? How can I have 2 answers?
One of them is extremes.
So what do I do?
Average this.
You would pick the
Yes,
one.
that's something where the x is at.
Hmm.
You pick the one that is positive.
We just pick the one that's positive.
Oh, okay.
We say, you're real, you're crazy. That's what we say. Okay? This is an imaginary world, so we'll just kind of, and you're gone.
We choose to ignore
Yeah, that actually comes up a lot in chemistry and physics. You'll get an imaginary answer and a real answer, but we're not working in the imaginary world, so we take the real one.
Yeah, we ran into this last year.
Okay, good. All right, well now, if we know that x equals 0.0385, well, our question didn't say what's x. We know that x equals whatever I just said.
I know theory.
I have to go and plug it in. So for here, 0.05 minus x, so the concentration of N2O4 is 0.05 minus 0.0385. And then the concentration of NO2 is just 2 times 0.0385. And that'll give you my answers, which are for N2O4, 0.115 molar, and for NO2, 0.0770 molar. Now, particularly whenever you're doing quadratic equation, algebraic sorcery, things are moving around all over the place, there's a preponderance of making mistakes. What would be an easy way to make sure you did not make a mistake? Check it. We know what the whole reaction should be. Plug those numbers back in. If you do 0.0770 squared divided by 0.0115, it better equal 0.513. If it didn't, you messed it up. Spoiler alert, it does. It does. Questions?